All right. Thank you guys for having me today. My name is Rebecca Siegel, and I'm at Virginia Commonwealth University in Richmond, Virginia. And I know my title is kind of a mouthful here, but I'm trying to incorporate all of the different components of my work life at the same time. So, um, so basically, I want to talk about some work that I am currently working on with the Summit P project, and I'll talk about what that is in a minute and how it ties in to enhancing college algebra classes in particular. So Summit P is an NSF IU's DUE grant. It stands for Synergistic Undergraduate Mathematics via multi-institutional interdisciplinary teaching partnerships. And we're in the midst of this grant at the moment. It was originally a 5-year grant, but through COVID and no cost extensions and supplements, we'll be going through 2023. And most of the funding for this grant is based on doing curriculum reform within the individual institutions, and also for site visits to share information across the institutions in the grant. So there's 12 universities across the country that are participating, and I'll throw up the website at the end of the talk if people are interested. So the big picture for this work is the notion that student engagement and retention of mathematics is increased if we engage applications that are real and resonate with the students. So to do that, we rely on the partner disciplines who use our mathematics courses as prerequisites or co-requisites to try to change the content of the mathematics course. And this is work that's been going on for quite a number of years. It grew out of the Curriculum Foundation project, and I'll say a few words about that in a minute. And is really focused on this idea of collaboration, both within our institutions and then within this consortium of other universities. And so the work at VCU prior to now has been building relations with college algebra and originally a lot of business, although that's morphed into some more science and pre-health over the years. So I've served as the coordinator for our college algebra class for about 10 years. And that was kind of the precursor work to the current grant that I'm on. But I'm really going to talk about the college algebra work because I think that's the most relevant to this group today. Our current work is working with differential equations and our engineering faculty and trying to support our engineering students. And then we're also moving into piloting some work with calculus in our science departments. So college algebra is the lowest level non-terminal math course that we offer at VCU. So we have a terminal math course for non-STEM majors, but college algebra would be the course that any STEM major coming to VCU would need to start in if depending on their placement scores. And so it's taken by quite a few students every year. We have lots of sections that are taught by many different faculty, adjuncts, grad students, term faculty, which are non-tenure track and tenure track faculty. And most of the majors of the students who take this course are in either business, and they will go on to a business calculus class afterwards, or they are in health sciences or regular sciences, and they will go on to take pre-calculus and then calculus. And after our conversation, listening earlier today, I threw this statistic in here. VCU is approximately 30-ish% first generation. I think the stat is like 32%. And about 30% underrepresented minority. And these are not necessarily distinct groups, right? There's probably a fair overlap in some of these students that are in both categories. And this applies both to our engineering student population as well as to our college algebra students. So this work really began in the early 2000s. VCU was teaching large lecture college algebra classes. The DFW rates were really high. And the department chair decided that this was obviously not a good thing. And so the department began to pilot some new directions for the college algebra course. So we started from Don Small's Contemporary College Algebra book, which is very application oriented. And then we extended his work to create our own applications that tie in to faculty from across our university. And again, the idea is to use real applications, motivate the mathematics from situations that come up in other disciplines, and to really engage the students in active learning and group work within the course. And so this content and structure was used as a result of the Voices of the Partner Discipline publication that came out from the CUPM committee and CRAFTY, which is the curriculum renewal across the first 2 years, that it really encouraged math faculty to listen to what other disciplines need out of the mathematics courses. And so this was a starting point both for the college algebra work and the work we're doing now, where we used what these reports summarized. It's a really great starting point to talk to faculty and other departments, because you'll get a lot of buy-in and agreement from your campus faculty who say, oh yes, we really do need students to practice their graphing and what do the different axes mean, and using Excel, and strengthening. Even when we talk to our engineering faculty, they really need students to strengthen their algebra skills. So a lot of what's in these reports will definitely resonate with your faculty if you approach them and talk to them. And so the process that we used both for college algebra and that we're using now with our differential equations course is kind of a multi-layered process of curriculum reform. And so the first step is to get consensus within the mathematics department. So discussing the priorities of the course with the math faculty, including tenure track and non-tenure track, and hopefully really garnering support from the department chair. In both cases, that's been very strong, and so has allowed us to really move forward quickly with changes to our curriculum. And then the next step is to reach out to the partner disciplines, the folks that are using the math courses for their pre and co-requisites within their disciplines. So for us with college algebra, we met with the business faculty, shared with them the curriculum foundations report, and got confirmation from them that these indeed were things that they wanted to see as well. And they really pushed us to include use of Excel. So this was, about 15 years ago. Now we've kind of moved over to use Google Sheets because we're a Google campus. And so, you know, this has been, was a really good structure to make curriculum changes from, because we had the endorsement of the faculty. The next step is then to look for existing materials. You know, no need to reinvent the wheel. There's lots of great material out there. And so that's a very good starting point to have. You know, like I said, we used Don Small's book. We've since moved away from that for a few reasons, which I'll share in a minute. But you know, that gave us a good jump start into restructuring our course. And then as time went on, we gradually prepared activities that were unique to our school, our department, our students, faculty interest, and things that we thought were fun to talk about. So the punchline, I guess, here for College Algebra is that this really made a huge transformation in our student success rates. So it reduced the DFW rate in going from the traditional large lecture classes down to these smaller modeling focused sections of College Algebra. And furthermore, and I think, you know, as we're talking about this STEM pipeline, it allowed the students to actually have better follow-on success. So students leaving this modeling course had improved performance. Even though we were passing on more students out of College Algebra, they were doing better. The pass rate in pre-calc was higher than it had been prior to this. Business calc stayed approximately the same, but got a slight boost there as well. So this was really a great endorsement for us to keep going with this course. It's obviously more resource intensive. We have smaller, you know, we went from 100 student large lectures down to, you know, 35 students in a small course. But it really eliminated a lot of the repetition or the repeating of the courses that students were doing, and allowed more students to actually progress towards graduation. So all of those are really great outcomes for that investment. And I think, you know, anecdotally, the faculty enjoy teaching this class much more, right? It's much more fun to teach a class when your students are succeeding and also engaged in the material. So, you know, when I teach this class, I don't get the typical, you know, why are we learning this? What's this for? Because they see the use of it right away in the class. So currently what we are using, so this has, you know, been a almost 20-year process. So we've moved away from Don's book, partly because it's not really in print anymore, but we also felt that we needed some online content support. So we had written our own like online exercises, but just didn't feel like it was enough. And so we moved into Explorations in College Algebra by Kimmy, and use their workbook. So the students purchase the workbook with worksheets, and then we get them access to their online homework system. And then we still supplement this with our own in-house worksheets, supplemental algebra review skills, and use of either Excel or Google Sheets. And so our assessment in the class is through the online homework, the class activities, which are often graded, and those are group work, but still collected and graded, and students get feedback on, and then, you know, normal tests and quizzes throughout the semester. So we also provide additional teaching support beyond sort of just a syllabus, a common syllabus. So we run a pre-semester training to support active learning, because like I said, we have lots of adjuncts and grad students that teach this class. So we make sure that everybody's sort of on the same page for how to run successful course. We have weekly meetings to keep everybody on pace. And then we also have separate sections of the class for students that have lower placement test scores that meet for an extra hour a semester to allow for just more class time, a little bit slower paced content rollout, more time for skills review as needed. And so I thought I would just share a few of the examples of some of the work that we've done. And if people are interested, we're always happy to share some of the exercises we've created over the years. We try to, this is some old slide, but we try to update the data so that we stay somewhat current. As you can tell, this one is a little bit old. But so we try to mix up the applications that we do from time to time. And so the idea is that students are using either Excel or Google Sheets. We also do this with calculator work or Desmos, where students are presented with some data, and then they are given instruction on how to graph that data. And then we talk about what shape that data has. So in this case, we might try to approximate this with a straight line. And so then we would talk about the features of a line, what the slope represents, reviewing y equals mx plus b, and all the components of working with linear equations. So this would happen, early in the semester, and we do this same type of work with, with different types of applications. So again, here's a negative relationship with the weight of a dirt racing bike to how much height it can get. And so again, asking kind of interpretation questions, having the students really engage and interact with both the data and with the function that we use to represent that data, to try to give some real meaning to these equations that they're looking at. Another example that we've made use of is some technology ones, maybe where you have some saturating behavior with number of subscribers, either with Netflix or Wi-Fi, or there's lots of examples here. So we could have exponential functions. We could try to motivate where there's then a saturation or turning point here. We can look at graphically finding intersections with where this function would top off at or where it would hit 300 million subscribers, and then use that to motivate why we would talk about logarithms as an inverse function. And so again, trying to really engage in actual situations and scenarios where there's information being presented, and then we're motivating the different mathematical equations to investigate those situations. One of the fun ones that the students and faculty always really like is a composition of functions where we have a forest trees are being cut down, which is affecting the owl population W here. And then the owls who would normally feed on the mice, if there's fewer owls, then the mice have greater population. And the mice carry viruses into the neighboring city or neighboring village. And so, we can talk about how as we cut down trees, we see an increased rate of virus spread among this neighboring population. And so again, really trying to drive home some different situations where you might look at algebra concepts in a slightly more real world style. And so put my email address up here. I'm happy to share content, and I will I'll put a link in the chat to our Summit P website if anybody's interested in engaging in that content as well. And of course, I'm always happy to take any questions that anyone has.